Now, in previous video, we discussed that linear equations, linear graphs, they had a constant rate of growth or a constant rate of decline. That means the rate of change in linear graph was constant. It was fixed. They were increasing with a fixed rate or they were decreasing with a fixed constant speed, right? But one thing, reality is not all linear. Second, if the functions or the systems are non-linear, their change will keep fluctuating. It will not be the same fixed value. They will not be increasing with the same speed. They will not be decreasing with the same speed. They will keep fluctuating. In case we have a nonlinear function and its graph is like this, and I want to study the change at 2 points, whether that change will make sense, whether that would be a true depiction of what really happens, or it would give me a misleading information. So let's see. I study the function at a location. My output is f of a, the height is f of a. Then I study the same function at b location and my output is f of b. If we look at it, my function had a bigger height at a, so the outputs were bigger values. At b, they are lower values. So from a to b on this length of time, my function had declined. So I have got a decline in the values, right? It has got a negative rise, so it has fallen. Okay, if my function has fallen from a to b, so this line from a to b represents a secant line. We call a line that touches the function at two different locations or crosses the function at two different points is called a secant line. So now if I'm studying my behavior of a function from a point to b point, from the outputs at a to outputs at b, and I'm looking at this ratio delta y by delta x, which is rise over run or fall over run. In this case, I'm looking at these two differences, f of b minus f of a, yani ke outputs at b location minus outputs at a divided by b minus a. So this way I'm looking at the slope of this secant line. Okay, this line is going down, that means the slope is negative, right? Now this is giving me average change. It's telling me that from a to b how the function has on average declined. It's not giving me information at every moment. If we look at it, we can also call this b location, as you take a location and you go at some gap h and then you get b location. So b location can also be called as a plus h. So if I'm studying, or x plus h if a is my x value, so if I'm studying this at x first and then I get some gap and the next location would be x plus h, so f of b will be f of x plus h minus f of a will be f of x divided by x plus h minus x. So x and x get cancelled, divided by h, right? So h represents my run value, the increment in x-axis, right? So either way, you call it this way or you call it this way. This one is the difference quotient that we have already discussed. These both are called by definition principle of finding the rate. So if we are calculating rate just with the common sense, by definition of the rate of change, we use this technique. But this is not giving me the true picture of the reality. In reality, the function has grown first till some point and then it has started declining. And while we are finding this average change, we just operate under the assumption that from a to b the function has just only declined by this much value. So that's not good. And even if I was calculating the function at this point, say, now they both are at the same height. So if I find the average change at this location, maybe I call this location as c. Now at c, both of the heights are same. The height at a and the height at c are same. So if I find the average value, that will give me 0. So would that mean that the function has not grown or declined? There has been no change from a to c at all? The algebra or the mathematics would say that, but in reality the function has grown a bit and then it has declined back to get to the same point. So we say that the slope of the secant line, or this rise over run technique, or this average change just gives us a good data to understand the past. So if I'm interested in understanding how the function or that model or whatever business portfolio it was, or whatever system optimization thing it was in computer science, or whatever field of studies, if I'm interested in understanding its past behavior, how it behaved on average, I'll go with the slope of secant line or this average change mechanism. But if I want to understand the present situation, how it is changing, I'm more interested in what happens with one more unit of change in the system. If I take one more step, what happens? If I sell one more unit, what happens? If I produce one more unit, what happens to the cost, or what happens to the revenue that I get in return? So if I'm interested in very minute changes or on a one step basis changes, I'm more interested in tangent line slope. What does that mean? That means bring this second point where you want to study the function as closer to the first point as possible. So if I move the point from B location to C location, now this has become my line. It is again a secant line. If I bring this C point even closer here, so it has become a D point now, my line would look like this. It's again a secant line. It touches at this point and at this point. But if I bring it closer and closer and closer, so close to this point that my next point is almost A. So this A plus H is very, 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 very close to A. So what am I doing? I'm applying the limit on H, the gap that I have created from A to B. I'm minimizing that gap. So I'm applying a limit on H, which is H goes to 0. I'm shrinking this gap so much, so much that both my inputs are getting almost to the same point. So I'm studying the function at a point other than A, but so close to A, as close as possible, right? So this next point would be almost at the same location, and if I draw a line now, it will be a tangent line. A tangent line is the line that touches a curve, a graph only at one point, right? So now if I study the graph with the help of tangent lines, it would look like this. So at A point, my tangent line has a positive slope. Near A, it still has positive slope. It keeps the same positive slope till this point, say D. At this point, the tangent line is flat. It's horizontal. It has a zero slope. And then after D, my tangent lines have negative slope. Now this is giving me a pure picture of reality. It says that the function was increasing from A until D point. At D it stopped increasing, so it had zero slope. Then it started declining and it had negative slope, negative slope, negative slope. So the decline in the function or in the company happened after D point. So it's not that from A to B it was a continuous decline, but it was a growth first till D point and then it was a decline. So now we agree that the slope of secant line gives us the average change. Average change is only good for past analysis, not for present or future predictions. For present study and future predictions, we need to rely on the slope of the tangent line. They give a better understanding of the picture. How do we get the tangent line? We bring that change which we were studying at two different locations to very, very, very close locations that it almost becomes a similar point. So if we want to bring the B location or the next location very much close to the A location, we need to apply limit of the gap goes to 0. So we mean to minimize the gap, right? So we take the same difference quotient, we take the same delta y by delta x, we take the difference quotient and apply limit h goes to 0. We minimize the gap as much as possible so that the two different points become the same point. Whenever you apply limit h goes to 0 on this rate of change delta y by delta x, it converts to dy by dx. Now we call it derivative. So from the slope of secant line, we came to slope of tangent line. The secant line now converted into tangent line when we applied the limit. And now this is no more average change. It's an instantaneous change. You are studying change on every next instant that's happening. That what happens if I walk one more step? What happens if I produce one more unit? What happens when I sell one more unit? What happens if I insert one more memory or processing chip? That's what derivative is. It gives us the true understanding of the rate of change, that how things are changing with respect to one another.